Okay, welcome back everybody. We're now looking at double displacement reactions and predicting the products of those reactions. I'm going to use an example that's in the survival guide. PbNO32 plus Na3PO4. We've got to predict the products of this. Just briefly, I'll give you an idea of what's happening in the reaction. We've got two aqueous solutions. AQ means completely dissolved, no solid at all. If we take these and we plonk them both into the same container, what happens is we get a solid. And what we've got to do is figure out the identity of that solid. We don't know what it is yet, but we will figure it out as we go. Alright, so that's just a brief overview of what's going on. I'm going to clear that out. So, in doing the same thing as we did with the acids, what we do is we join the Pb with the PO4. Remember what we did before? We did Pb, PO4, and then the Na will join with the NO3. Now notice we only take one of each over to the other side. I know there's three, I know there's two, it doesn't matter. All of that will even itself out in the end. Don't worry about it. Now the next thing we want to do is we want to put charges on these so we can figure out the compounds that we're getting over here. So we know that Pb is with NO3 If I drew a picture of that, it would look like this. We know that NO3 has a -1 charge. We can get that off the polyatomic ion sheet. If that's the case, that means that the lead must have a 2+ charge to match it, which means that if it's 2+ there, it must be 2+ here as well. Alright, so I'm going to erase that. We've got that charge figured out. Now we need to figure out the... whoops. Now we need to figure out the charge on the phosphate, which we know is... sorry folks. 3-, and we know that the charge on the sodium is 1+, and we know the charge on the nitrate is 1-. Now, in the same tradition as what we were doing earlier, we rewrite the problem, and we figure out the compounds that we're going to get here. We've got Pb 2+ and PO4 3-. That'll give us Pb3, PO4 2. If you don't know what I'm doing, go back to Module 8 and you'll see plus NaNO3. Now, as I said earlier, one of these is going to form a solid. We've got to figure out which one that is. So we've got lead and phosphate and sodium and nitrate over here. So I go back to, in the Module 10, you'll see this solubility chart. If we look at sodium and nitrate, what you'll notice is that it is all AQ. So sodium and nitrate is AQ, which means that, looking at the key, that says soluble. So that's not the solid. Well, let's look at lead phosphate. Okay, so lead phosphate. Lead and then phosphate, that gives an I. That's insoluble according to the key here, so that's going to be a solid. So there we go, that's going to be S, and the rest of these are going to be AQs. Well, we're not done yet. We still need to figure out how to balance this reaction, and I think the best thing to do in this one is to look at the leads first. So we'll go for Pb3, so we'll put a 3 in front of here, that balances out the leads. But look how many nitrates we've got. We've got 6 times 2, that's, sorry, 3 times 2, that's 6 nitrates there. And that means I'll put a 6 in front of here to balance the nitrates. And we've got 2 phosphates here, so I'll put a 2 in front of here, and that will balance out that. So now the entire reaction is balanced, and that is our part A done. Now the next part of this, part B, is to work on figuring out the complete ionic equation. And here's what we know. If it's an aqueous compound, that is, it's completely dissolved, then it's going to completely split up into ions. If it's a solid, it's going to stay exactly the way it is and will not change. Okay, so I like to draw pictures, but obviously you don't need to do this when you're working it out, but I'm going to do it here so you can see how this works. If we've got PbNO3 2 and we've got 3 of those, here's what it looks like. Negative, negative, and that's 2 plus. Negative, negative, and 2 plus over here. And we got 3 of these. So all I'm doing is just drawing a picture of what I've got in the reaction. We've got 3 of these entire things here. So if I was to see how that splits up into ions, that would split up into 3 Pb2+, see, 1, 2, 3, and 6 nitrates. That's 1, 2, 3, 4, 5, 6. And so that's how it works. That's how you figure out how these things split up into ions. Okay, I'm going to clear that out and we will look at how that figures. So, as you can see, that's going to split into 3 Pb2+, plus 6 NO3-. And do you have to put the charges in? Yes, you do have to put the charges in. There's no way out of that. Now, if you get confused and you're not sure what the charges are, look back up here. You'll see what the charges are. 2 plus and 1 minus on the nitrate. And you'll see we've got 3 leads and we've got 6 nitrates. And that's how it splits up. Now over here we've got 6 Na plus. And again, I can get the plus from over here. And we've got 2 PO4 3 minus, and again we get the 3 minus from up here. As I said, the solid will stay exactly the way it is. Pb3 PO4 2 solid plus, and this will split up into 6 Na plus 6 NO3 minus. And there you go, that is part B. That is the complete ionic equation. Now you'll notice I probably should include AQs here, but I don't mind if you don't. If it's got a charge on it, you can be pretty sure it's aqueous. I do like to put an S on the solid though, just to sort of keep things even. But let's make sure that we have got something that's correct here. And you see we've got 3 leads here, we've got 3 leads here. We've got 6 NO3 minuses here, we've got 6 NO3 minuses here. We've got 6 Na pluses here, we've got 6 Na pluses here, we've got 2 phosphates here, we've got 2 phosphates here. So everything appears to be balanced, and this is called the complete or full ionic equation. Now if we want the net ionic equation, what we're interested now is just what reaction will form the solid, and that's just between the lead and the phosphate. What we can do is we can cancel what is exactly the same on both sides of the reaction, and that would be the nitrates and the sodiums. All of those will disappear, and the net ionic equation is going to be 3 Pb2 plus 2 PO4 3 minus. And that is the reaction that causes the production of the solid. So that's Pb3 PO4 2 solid. And that is the net ionic equation. And that's the easiest way of doing it. In the next part I will show another example, and you can see how it goes.